Okay, so in this video I want to talk about reciprocal functions and the graphs that come with them. So a reciprocal function is 1 divided by some function, okay? So f of x could be any sort of function. It could be like x plus 1 or any sort of function. So let's just say that's equal to y. And usually it will come out as an asymptote, or always. It'll come out as an asymptote. And what an asymptote is it is a function where a line approaches some point. So like this is just an example, but let's say it looked like this. Y is slowly approaching some number way off, right? That is undefined. And that's what an asymptote is. It would actually look like this. Well, in most cases. So that's what an asymptote looks like, but it doesn't only apply to these functions. It can also apply to other types of functions, but with these, it's always the case that it's an asymptote. So let's actually give an example with an actual number. So let's just say it's 1 divided by x. Pretty simple, right? Just the simplest it can get. Well, one of the simplest it can get. So 1 divided by x equals y. Let's make a graph with that. And we know that, let's start with 1 divided by 1. 1 divided by 1 is going to be 1, right? So at 1, it's going to be 1. Okay, sorry, 1, it's going to be 1. Okay, so we can graph that point. What about at negative 1? At negative 1, it's going to be negative 1. Okay, like this. Now at 0, it's actually going to be undefined. 1 divided by 0 is undefined. And we can see that as x slowly decreases on this part, it's slowly going to increase. So we can draw a line like this. It's going to increase, increase. And a line like that, an asymptote. And it's also going to go in this direction as well. So, why does this work? Well, when you're doing 1 divided by x, as you slowly decrease x, it's going to get bigger and bigger and bigger until you reach 0, right? So that's why it keeps going to an undefined number. Now on this part right here, the lower end, as x becomes bigger and bigger, right? X is becoming bigger and bigger, then this number will become smaller and smaller, right? So y is getting smaller and smaller as x becomes bigger and bigger. On this side, it looks the same except, sort of flipped. So the same rules apply here as x becomes actually bigger in this case, right? Closer to 0, you're going to get a more negative number, right? 1 divided by negative 0.1 is going to be bigger, is going to be, smaller, I guess, than 1 divided by negative 1, right? And over here, the same case applies. So we see why these asymptotes come from functions like these. So how could we transform this sort of graph? Well, if we wanted to move it left or right, we could just add a number to it, right? Let's do that on another page, because it's getting kind of... So 1 divided by x, and let's say plus 5 equals y, okay? Now this is going to move it up and down, okay? So if you have a graph like this, and this is your normal one, this is regular with like just 1 divided by x, that's what it looks like normally, and then this is when we transform it. It's going to move up 5, okay? Similar to other functions we've seen. So, the reasoning behind why this works can be found on Khan Academy, or maybe even some of my other videos where I do transforms on parabolas. Anyways, so that's how we move it up and down. Now how would we move it left and right? Well, we could move it left and right by changing the x. So let's say we do 1 divided by x.
Okay, so this is actually going to shift it right because we're subtracting x by 1. So now let's actually look on a separate page and see what it looks like on a graph.
Okay, so sorry about the continuous change, but 1 divided by x minus 1 equals y. Let's just see what that does to our graph. So usually it's like this, and then it's like this, right? That's our regular graph without any transforms. And now it would look like this. It would actually shift right, like that. So it shifted right a bit, and why that works is also in the parabola video, but anyways, that's how you shift it. And how do you change these lines, just like part of the line? Well, if you change this numerator up here, actually, and you increase it, let's say, to 5, let's say 5 divided by x equals y, okay? So now x actually reaches 5 before it reaches the top, okay? So it's like multiplying this function by 5, okay? So every single point on this curve is going to be 5 times what it was before. So now it looks like this. It's going to be 5 times what it was before. It's just going to be a taller function, a taller, wider function. It's going to be much farther apart. So that's how we sort of spread out these two. I don't know if you can see with my drawing, but slowly these two curves, or these two asymptote parts, I guess, are slowly going farther and farther apart as you increase the numerator. That's because that's basically saying, well, 5 divided by x is basically saying 5 times 1 divided by x, okay? So let's just say 1 divided by x is our base function over here, and you're multiplying it by some amount. So you can imagine that maybe this point is going to be 5 times higher. This point is going to be 5 times higher. This point is going to be 5 times higher. And it's just getting farther and farther from each other. They're getting farther and farther from each other. This is going to be 5 times lower because it's negative. 5 times lower, negative. It's going to be farther and farther apart. So those are most of the transforms that you'll probably, if you'll even see them, in grade 11. And that's asymptotes, and that's reciprocal functions. Thank you.